Hello. Is this thing on? I think so. Hello, Internet. Welcome to the stream. My name is Chris, and this is Fully Defined. And tonight, we're going to spend around 2 hours working on SolidWorks and putting together this Lego set. Boba Fett's Starship Microfighter, set 75344. If you've been following along with the stream, every fortnight, stream for 2 hours and doing some SolidWorks modeling. And we have been working on modeling all of the parts in this set, which I completed off stream last week, not including the minifigures. And so we've done all of the geometry that you can see here. And for anyone wanting to take part and follow along with this practice, bit of fun, the assembly that we're about to do, you can do so with your own files by going to the link in the description, and which takes you to a Google Drive, downloading, unzipping the files, and then opening them up in your own version of SolidWorks. The only requirement that you have to do that is you need to have a SolidWorks version that is 2023 or newer. If you have one that is older than 2023 and you jump onto this stream in the next 2 hours, let me know. I will export a step file package for you or an XT file package, and I'll post that as well. Otherwise, if you miss the stream and you want the files, you'll have to wait till I go through and edit and post them all into the Skool community, which I'll do sometime in the near future. So to start off the stream, and before we get into the assembly, I need to bring up the assembly instructions. We have everything available in the description, so you can get both the files and the assembly instructions. I want to give you a bit of background on what all this is about. I run a little Skool community, slowly growing, nudging up to nearly 100 members. It's free on Skool, so Fully Defined. And in this community, it's for product and industrial designers and engineers who want to learn and grow SolidWorks while having some fun. So you might be a student or a graduate or a hobbyist or a maker, DIYer. And I have a couple of projects in here, different Lego sets. And I have this CAD library where you can go through and practice making your own Lego parts, even if you don't have them in front of you. Het Patel, hello. Welcome to the stream. Thanks for joining. Het, are you going to follow along and download the files and have a go at the assembly? I hope you do. For anyone searching, I'll have a look right now, because I'm going to show you the process of how to download them and then open them up and bring them into SolidWorks. But here in the classroom, the Fully Defined classroom, you'll find a couple of different projects. We have the off-road buggy, the Volvo wheel loader, and the motorcycle, and soon we'll also have this as a more introduction project, so quite a simple and easy one. All right, Het, perfect. So here's what we do. we're going to go to the description in the video where you can see the link. Just going to pause that ad. So go in the description and you'll see here in the description where you can download the parts and the instructions. So to download the parts, open them up. I'll just minimize that one. It's going to take you to a Google Drive. It's my Google Drive. The files are safe. And you'll see this preview. So this is showing you all the files that you're going to download. It's going to download it as a zip file. So you hit the download button. That should download them for you. Save them in your downloads folder. And then to use the files, you have to extract them first. You can't open SolidWorks files directly from a zip folder. So what that means is I recommend setting up a folder where you can drop the files. So I've just put a temp folder here. And then when I open up my zip folder, which is this one, these are all the parts, and there's one assembly in there as well. So we're going to grab all those parts. I'm going to extract them into another folder. It's very quick. Get rid of that. Get rid of that. And then in this folder, you will find there is one assembly file. And if you open that assembly in SolidWorks 2023 or newer, you'll get all these parts. That's how you do it. Nice and easy. If you have any problems with that, if you're following the stream later and you have any issues here, please put a comment in the video and I'll add some more instructions or more ways that you can download and open them up. Now I'm going to close this file and open up the one that's actually on my hard drive, which is here. And I'm also going to open up the instructions. So the instructions are also available from the description in the video. So I think it's the next link down. So just give me a second while I find those. And then we'll get going. So as we move through the assembly build, we're going to follow the instructions just like someone would with a little Lego set itself, and I do have it here for reference. This is what we're building tonight. This little microfighter, Boba Fett microfighter. So I don't quite get it in focus, but it's a nice little set, and I reckon we'll get through it in pretty quick time. FPV Kev, hello, how you going? Welcome to the stream. If you're interested in following along, you can download the files from the description under the video. Now, just getting to those Lego instructions. And here they are, popping up. Now, when I use these instructions, like anything, I like to work dual screen. I have an ultra wide monitor here, so I can often have these off to the side. I might have them on screen a little bit so everyone here can follow along. 2-page view, show cover page, and then we want to go down a page at a time. And we're going to start here from step 1. So I'm just going to make these a bit smaller on the page. For reference, I'm going to pop them in this corner. Try and keep them out of the way as much as we can as we're building. No, thanks. Close that. All right, that's going to stay on top. And so you can see all the parts we've got here. Cool, Kev. The future set 77256. We'll have to have a look. all the parts that are prepared for you here match everything you can see on this last page, last 2 pages. And that's how we know we've got everything. I've roughly put them in order. Now, one thing we don't know is whether or not they're all perfectly accurate. So what we'll find as we go through the assembly, we'll probably have some interference issues, some parts maybe not fitting, in which case we're going to go through and edit them as we go. Now, for me, I'm editing the files that are live in my public folder. So as I do those edits, and when I update the export folder, anyone that downloads the files later, you might have updated files. Just to explain that. Okay. And as we go through the assembly, I'll be giving you some tips and tricks about how I set up and manage an assembly like this. It's not overly complicated, this one, but there's definitely some things that we can do along the way that are going to save us time, make us more efficient, particularly using the mirror component tool for something like this, where there are 2 sides, left and right, which are very similar. So I hope you enjoy. Now, anyone that's watching, if you have questions, comments along the way, please ask. I do have one question from my school community, which I will answer a little bit later in the stream. But yeah, if you've got anything to chat about or ask about, feel free. Kev, no worries. I know that. I know that feeling too, but that's part of the fun here. All right, so let's get into it now. I'm going to flip over to a larger display. There we go. And you'll see how I've set up all these files. Yeah, they look kind of organized here. I've just put them in a folder for assembly ready. Nothing is mated, so I've got no mates in this assembly. And I've got my planes here. And if I show those planes, it's going to give you an idea about positioning. I just want to move all this stuff away from the origin so that I can do my work, move things, mate things, etc., without him being sort of in my vision there. All right, so I'll just move those to the side to start, and then the very next step, we're going to start the assembly. There's a few ways we can do that. We can like fix the first part, or we can just leave it floating. I would kind of like, if I think about a design that I'm putting together, if I haven't already designed it from a master part and the plane's already organized, then I'm trying to look at the finished product here and think about what orientation the finished product's going to be and whether I should mate the first part in a plane that's going to match that. Because the planes will matter, particularly like the right plane or the front plane if we are using the mirror component tool. Okay. So from my point of view, I think what I'm going to do with this one is actually build it like it's shown. So I'm going to have it laying down to start. I'm going to have it like this. All right. And then later, this first part, I'll be able to free up, like remove a fixed mate or whatever and move it and rotate it up. Or show you some other tricks where we might actually keep the whole assembly like this, but we can put this assembly into another assembly to then get any orientation we want. If we get time at the end of this stream, we'll do a little bit of rendering. But we'll see. We'll see how we go. So maybe it doesn't matter too much in this one. It is a pretty simple model. Kev, if I mirror an L-shaped piece, why does it mirror inverted? We're going to find out. We'll talk about that a little bit in this stream. Okay, now, very first thing, I want to make sure my front plane is the front of the object. And then if I go isometric this way, I kind of want it facing that angle. So I'm not going to have, here's my first part. I'm not going to have it facing like this because I know this part goes up and down the middle. I want the right plane to be in the middle of my object, middle of my design. So I'm going to grab my rotate component tool, going to grab this part and just move it around a little bit. And then I'm going to look at this part And when I click on that, that's going to find it for me in the feature tree. I'm going to find what plane is in the middle. You see the way it's modeled, the right plane is not in the middle. The front plane is the one in the middle. That's fine. All right, could be front type, right, whatever. But now I'm going to hold control and the right plane, and I'm going to make them coincident. All right, and that's my first part. And the other thing I'm going to do just to get started is I'm going to mate the top plane and the other one to stop it moving around, which is the right plane. So right and front. And this is going to fully define that part. Those are the first three mates of my assembly. I know later if I want to rotate the object, I can delete those mates or suppress them. And I'm going to make a new folder. So I'm going to drop this one out of this folder. So to move a part in your feature tree, so next thing I should do, I'm going to save this file, save as. I'm going to change it to assembly whip work in progress. So I keep the assembly ready one there just for reference for other people. This is my work in progress one. That part, to move a part around in a feature tree like this, to move out of a folder, I'm going to click it, drag it up to the folder name, if I can. Now, I've been getting errors with my SolidWorks sometimes with moving parts around, and often it means I need to restart my SolidWorks. It's a bit annoying. So right now, it's not letting me drag anything, which is going to be very, very annoying. Yeah, there's no reason it should be doing that. So I'm just going to close that file and try opening it again. And if this doesn't work, I'll do a quick restart of SolidWorks. It'll be very quick. I don't know why the error comes about. I do notice that it happens when I've had SolidWorks open for a long time, or I've had a file open for a long time. And it happens at different points. Sometimes it might not happen in assembly, it happens in a part where I'm moving features around in the feature tree. If for some reason all of a sudden I can't move features when I normally should, I know that there's an error, something going on. I save my file, close, restart SolidWorks, and go again. So if we see now, this one here, see I can drag it now. And now I'm getting an error again. So there's something going on a bit funny. And I don't know if it's necessarily my laptop or something with this version of SolidWorks. See, right now it's even hung on do nothing, this little symbol. Which, pardon the interruption, but a great time to answer any questions if anyone's got any that are watching the stream. All right. So, yep, definitely an error because I can zoom in and out and I can even rotate with my space mouse, but I can't select anything. So in this case, if you've ever encountered an error like this or similar, first, you should still be able to save, so Control S to save. Then, after that, you want to, now my menu bar at the bottom is closed off, but you want to go to your task manager. Yeah, just SolidWorks being SolidWorks. Task manager. You can see I've got a few things running, but this is how you can restart or close it. Hopefully you've saved your file so you're not losing anything like I have here. I'm not going to lose anything. Right click, end task for SolidWorks. It's going to shut it down. And then I'm going to start it up again. And then I should be without errors for the next 2 hours or so without this, while the stream's going at least. It's not too often I have to do this. maybe a couple times a week, once or twice a week. But I've become very proficient at saving and also identifying when the error's happening, when the bug's happening. So usually as soon as I see it, it's just a quick shutdown, restart. My files normally open within a minute. That way I don't lose anything. So SolidWorks is reopened. And I'm going to go to my home, reopen the file. Yes, Kev, I'd be happy to show some pics of your progress if you are interested. Let me know. All the crowd can check it out. Okay. So we're opening that part. I can rotate my view around now. I'm sure I'll be able to move and work, and then we can start making some progress. Slow start, sorry. But a good chance for people to jump on and catch up and download the files if they haven't already. Okay, here we go. Assembly ready, plate, drag it. Okay, so if I drag up here and hold Alt, it's going to move it out of this folder. And so you can see the part there in the feature tree. I'm going to make a new folder, call this assembled. And this is not for any particular reason other than just getting organized with my feature tree. I'm going to hide these two planes as well. I don't expect to need those. I will keep the right plane visible so that we can just kind of keep our bearings. All right, and we can always come back to isometric view as well if we get lost. Okay. So save, and now next step. Now, I know from the orientation that the green part that we're about to do is higher up on the starship. So I'm going to do that towards the back. So we go over here to our parts, and I'm going to grab that part over here. And now we're thinking about the mates. I'm going to try and teach you as many shortcuts or efficiencies as I can in this little stream. So the first one is pretty obvious that, okay, we want to mate, let's say, this stud and this stud, because that's going to line up the parts if we've done the dimensions right. Now, when I select those two faces, I select one by clicking, I hold Control, then I select the other one. And see the little shortcut menu that pops up? I'm going to go here to concentric mate and add that. And then this other option that comes up is to flip the alignment or to lock the rotation. I don't need to do either of those. I'm just going to leave it. I'm now going to move the part up. You can see how it rotates, but it is aligned. And the next step, we're going to do another mate. And I've, in the past, for a good 15 years, I did my mates a lot by clicking the mate tool and then clicking the faces. Now, that's okay, but a quicker way of doing it is just selecting the mate tool entirely and just selecting the faces that you want to mate. So let's say this one and this one. And then I let the pop-up do its thing, and then I can just choose the mate here. And it's very, very quick. Nice and easy. And that part's now fully defined. And so if you are a beginner with SolidWorks and you don't understand fully defined in an assembly yet, that's where your parts are fully defined with reference to the origin, just like you would do in a part file with either sketches or your geometry. So if we look at this folder here, this part, we can see next to it, there's no minus sign identifying it as an underdefined part, which means it's fully defined. Now the whole assembly still says underdefined because all the other parts can still move. But these two parts here, they're both fully defined. I'm going to drop that one down in that folder, save, and then keep going. Kev, I've got those files, they've come through. We'll do a bit more of the stream. and then I'll jump over in Discord and have a look. I do have them. Thank you. Well, at least, Kev, I've got your message, but I'm waiting for the images to come through. Anyway, I'll look at that later as soon as they come. All right, next parts. We're up to step 2. We will move quicker as we go. All right, so this one here. Any tips or tricks here? If you can identify which parts need to be mated, you do not have to rotate the part first. So I can select this stud and this stud and go concentric. I can just grab around. Yep, that looks good. And then the mates I do, I don't have to do another concentric mate. I can just do a parallel mate. It's going to give me the same thing. And then because these parts here have the same height, 3.2 millimeters, 3.2 millimeters, I can just select these faces and make them coincident. All right, and it's very quick to get that part then assembled in the right location. And you can see from what I've learned from previous modeling, there's already clearance built into these two parts. So the fitting is looking okay. Let's keep going. All right, step 3. Now step 3 says, hey, turn it upside down. We're not going to actually change our mates. We're just going to change our view. And then we're going to have one of those round parts and 2 of those smaller grey ones. So I've got this part here, and then the small grey round ones. Let me see where it's hiding. This one here. So I'm just going to bring those over towards the assembly. So I do regularly do this. I'll move parts closer before I get to mating. And so this one is upside down. That's fine. So this is an example here where I'm going to select the 2 faces to make them concentric. But then in the next pop-up, I'm going to flip the direction. Okay, and that's popped it down here for me. I'll just bring that back up. And now if we're trying to find the right height for this one, it's probably going to be these 2 faces being coincident. Okay, and that may lead to some interference in this shape, which we'll deal with later. Right now, the process we're going through is we're going to try and mate everything, and then we'll go through and do interference detection. All right, next ones. So we're dealing with the underside of these Lego parts, but we still have some circular geometry that we can use to get them fully defined. And we still have some parallel surfaces, and because the parts are the same height, coincident faces. And we can see, look, the heights are the same, the clearance is there, so that is nice and quick to update and continue with. All right, are these parts okay for you guys? Not too dark? You might notice my display settings, I normally have all these off. Let's come back to isometric view, and I'm going to save this view here as assembled. All right, so that's my view orientation pop-up. So if you want to go to that view, you can see them here, assembly ready, which was all the parts in the original file before I started moving things around, and then assembled. Or I hit the space bar and I've got the same options. Cool, Kev, I've got those images now. Nice. Okay, so 3 parts. Step 3 done. Step 4, okay, we want to go back to the underside. I shouldn't have rotated around. We're going to find the 2 transparent orange parts. Now, when I'm moving around my assembly, I'm usually just using my scroll wheel to zoom in and out. And depending on where your cursor is, you will zoom in towards your cursor. So if I want to zoom in over this section, I move my cursor over there and then zoom in. But when I zoom out, it always just zooms out straight from the middle. So my cursor could be anywhere and it's going to zoom out from the middle. But if I want to, let's say I'm over here and I want to zoom in on this side, I move my cursor and I move the scroll wheel and it's going to zoom in to the position of the cursor. Nice little trick. Okay, next step. This one here. Now, you might notice I skipped one of these. I'm going to get to that one soon. We're going to do a few more parts and then we'll do a mirror component. All right, so hang tight for that one. Now, we have a transparent part here. If you're having trouble mating parts like this, you can turn the transparency off or on. When it's transparent, like it can sometimes be hard to select the right surfaces or edges. If you ever have that trouble, if you hold the Shift key, it's going to select whatever surface is the top surface. Now, we're going to make these two faces here. So concentric. I'm going to make this face and this face. Also coincident. And then I'm going to rotate this around and make these two parallel. All right, our clearances still look pretty good, so I'm pretty happy with that. Save. Okay, let's flip back around. And we'll do this step and then we'll do a mirror component feature. Okay, so I've got the two parts here. I think it's this one I need. This is the right side. And I'm going to make these two concentric. I'm going to make these two coincident. I'm going to rotate this around and make this parallel. All right, and now we're going to experiment with the mirror component feature. So we've got three parts we want to mirror. Let's save first. And I'm just going to hide this while I give this little demo. So we've got one part on the front, two parts on the rear. These two, we want to mirror those components. We're going to use, well, first up, we're going to select the plane. And then I'm going to go to linear component pattern, drop down, mirror components. The first thing we need to do is select the components. So the parts that are symmetrical on the back, this one, and see the transparent ones give me some issue. But if I hold Shift, then I can get the faces. Okay, those two. I'm going to press, if I just press the tick, very easy, it's going to mirror those parts without any concern at all. All right, that's a very quick way of using the mirror component feature. I'm going to edit that feature. And now I'm going to select this one at the bottom. And let's just see what happens. We get this weird thing, right? Where not only has the part changed color, okay, I understand why the parts change color. That's just an appearances thing. I'm going to just fix that very quickly. All right. But it's kind of flipped the orientation and not in the right way. Now it's kind of mirrored, but not exactly the way we want it. And that's because we haven't been through all the options that the mirror components tool gives us. All right, so if you've got a simple mirror, you can just do it. straight away. Just select them, put the plane and press OK. But if you've got things that are not symmetrical and you're finding they're mirroring the wrong way, you want to go through the steps. So I'm going to click here on the arrow. And then you get a few more options. Now the mirror type, you can choose. We're going to leave that as is. And then the orient components gives you some options. And depending on which one you select, you can change the option as you go. Now, dynamic help might give you some additional information. Yep. So you click dynamic help, and then when you hover over these icons, it's going to give you a bit of an explanation about what they do, like what impact they'll have on how it's mirrored. And so my recommendation here is very simple. You find the part causing you issues. In this case, we know it's this wedge part. And you can see the little icons here, how they're different. So for some reason, SolidWorks thought that we'd want this selection, which is X mirrored and Y mirrored and flipped. I don't know why it would do that. If we just change that to both mirrored, you can see even then it's not the right selection for us. If I go to the next one, again, it's mirrored but not right. This one, not right. The last one, create opposite hand version, that's actually going to create a new component. Now that can be okay if you've only created one side of a part and you want to create a left-hand part. And what that will do, if you click on the arrows for the next step, you can see the opposite hand versions, and it's going to create a new file based on the original. And you can choose to add a prefix, a suffix, or custom name the file, right? So you get to name the version. In this case, you could call a different number on the left. When you press the tick, it's going to save that new file. It's going to put it in its position, and it's going to have a reference to the original file, which is a very similar process to how we actually created this part over here in the first place. So we've already been through the process of creating a right-hand, left-hand version of this, so we don't need to do it in the mirror components feature. But for anyone out there who's experimenting with this, it's a good tool to play around with and try the different options to see if you can get one that works. Now for us, we have the opposite hand version, so I'm going to go arrows back to the start, and I'm going to unselect that wedge part and just press the tick. For my assembly, this one here, I only want to mirror the simple parts. If a part is not mirroring using the basic tools, I'm going to leave it out and just recreate the part. Hope that makes sense. I'll add in now, bring this part down and mate it into position. So I knew of this issue ahead of time because I've experienced it before already in normal work when I've been designing things that are symmetrical, etc. But I've also experienced it in some of the Lego sets that I've done. The off-road buggy being the first one, where obviously there were a lot of parts on both sides. We used a mirror component pattern for that one as well. So I had a bit of experience and expectation that this is exactly what was going to happen. Cool. All right. So good step done there. Save. And let's race ahead now and get a few more parts done. So when we're mirroring like these ones here, we can see in the next step, step 6, it's putting down 2 of these parts. I only need to put down 1. And then I might just put down all the ones. Like I don't have to update the mirror feature every single step. I can just do it at the end. Or I can do it when I get to a point where there's enough detail there and I want to get something in the right spot. Yeah. Now, in this little example here, I've just mated something in the wrong place. So I'm going to show you how we fix that. First, I'm going to add these other 2 mates. Now, want to add a coincident mate between these. All right. So you can see this one, actually, I should have put it on this face here. FPV Kev, my studs don't always line up, so I cheat and make them parallel as well as concentric. Yeah. Kev, do you want to know the trick to get the studs to always line up? The trick is all the studs need to have an 8mm spacing. Now this gets harder when things start going at different angles. But yeah, keep to 8mm and that should help. All right, so we've got a mate here on this part that is wrong. We want to change it. You can, of course, browse through your mates, find it, it's this concentric one, and you could delete it and do a new mate. Or you can edit it and just change the selection. A really good way to identify mates for a part is to click on the part, and then you click on this icon here, which is View Mates. Or if you're looking on my screen, you can see in the breadcrumbs up here, it's going to show me all the parts, all the mates that are associated with that part. So here I can see the concentric one. I can then click and edit that mate feature, and I can see the two selections. And if I select this one, I think if I select a new face, it's going to override it. No, I have to delete it first. So delete that selection and then select the new face. And because they're the same type of geometry, they're both circles in this case, it's going to keep the concentric mate. If I tried to select something like this face here, or this face, I get a warning saying this entity is not valid for the current mate type. So it'll give you a warning if you're selecting something that won't work. Press OK, updates the mate, and I can keep going. All right, looking good. Now, if I want to keep my folders organized and I want to keep the assembled parts in the assembled folder, I can just select everything here, and that'll highlight for me the parts that are in the other folder. And then if I want to, I just drag them all down into the assembled folder. I might have to do them one by one, actually. It can be a little bit annoying. I thought I could drag them all in one hit, but I think that's only if they're all grouped together and I sort of manually select them like this. This is completely optional. This is just me trying to stay organized with my parts. You don't have to do this. All right, I'm going to save, keep going up to step 7. This is the smaller step. I'm going to click that, drag, bring that over. Kev, it's the gaps in between is the issue. They're all 8mm apart though. Okay, that's good. The gaps in between, I've learnt that if you have a part which is, roughly 16mm, it's going to be underneath it. So 15.8, that means I'm always going to have a 0.1mm or 0.2mm gap between parts. Between these two parts here, I'm always going to maintain that clearance. You can see all my parts here have a nice little gap, consistent gap between them. My Lego parts weren't always like this, but they are now. Edward, hello. Welcome. You are late, but I'm sure you're going to catch up very quick. Welcome to the stream. I've been saving your question as well. I'll get to that in around 15 minutes. Edward, to catch up, you want to go to you've already got the files. You'll catch up pretty quickly then. The link in the description will also take you to the Lego instructions, which I have here. So you can download a PDF and use that for reference. I know Edward is one that already had his files prepared, ready for the stream. So please catch up. Let me know when you caught up, and I can then answer any questions you have about the model as we go. All right, we've done a few tips already on mirror components and mates and orientation of parts. We're starting to get into the swing of things. Probably starting to find some interferences. But yeah, starting to move a little bit, which is good. And there's a few people joining the stream, so welcome. Anyone hasn't been before? All the files you can see on screen here are available for download for free. There's a Google Drive link in the description. You can download your files. You need SolidWorks 2023 or newer. You can open up the assembly and start modeling straight away. Now, are these the same height? No, they're not. All right, so if you make a selection that's wrong when you're doing your mates, just hit the undo button, and that'll just take you back, and then you can make a different selection. In this case, I might select this underside and this top side, and OK. All right, and that saves you a little bit of time. FBB Kev, it is more challenging than the Technic ones. Well, it could be. I think these are the first series I've done without Technic parts. I do like the Technic ones though, so I'll probably go back to those soon. Christopher, Candy Oats, welcome to the stream. How are you going? Nice to have you here. All right, so that's another part that I will mirror later. So let's just keep going with the steps. So we've got a simple black part coming over here. So click and drag that one. Now this one doesn't have any studs on the top. What does it have on the bottom? Okay, this is a bit of a different example, this part right here. So first up, what we can do is mate the face. So a coincident mate there, that's going to bring it up to the right level. And then I'm going to just reposition it. So this part here, there's no round parts on this one for me to mate to. So no studs. You can see underneath it, I just made it transparent. You can see underneath it, yeah, there's not much I can actually mate to for this. All right, so I'm going to have to use some planes as my geometry to mate. So let's find this part. That's this one, tile 2x2. And if we have a look at the planes, I can see that the right plane is going right through the middle. So I can select the right plane of the assembly, and I'm going to mate those two. And it's going to move it ever so slightly into the middle. All right. So now it's mated in two directions. And I can only move it up and down. So next, we're trying to find some sort of reference that we can use to locate it in this direction. And what comes to mind is doing what's called a width mate. I think it's a width mate. Hold on, let me just double check. It's under the Advanced tab. And then, well, symmetric is another option, but width is probably better. Okay. Now, with the width mate, what we're going to do is I'm going to select two faces on this part. So hold Control, select those two. The order of selections is important. So select those two first, and then I'm going to use this gap. And I'm going to use this gap because I know the gap is right in the middle. So I select those two, and now I'm going to press Mate. And SolidWorks knows, because of my selections, that I've got 4 selections and they're 4 faces that are kind of parallel. They don't always need to be parallel though, just so you know. They can be at an angle like this. It'll still work. It's going to put width selections 1 and 2, and the constraint is centered. You can also select a free dimension or a percent to move it at a certain position as a width between those things. We want centered because we want it right in the middle. I'm going to press OK. And now that part is fully defined. Fantastic. Make sure I'm saving as we go. Last thing we want is another crash and to lose our work. So Control S very regularly. All right. Now, next up in the series, we have a little a group of parts that are going to become, it's a little sub-assembly, but not yet. I think later in these instructions, this sort of section here, this is where we might do a little sub-assembly. All right. But for now, I'll just keep doing these one by one. So we're putting these parts together. It's another example of something that we're going to mirror. Okay, so that's good. I'm just going to move these a bit closer. They're all a little bit far away. Okay. So I'm going to grab the parts that I want. I want one of these. I want this one. And I want this block here. And what I find and why I like to usually work with parts that are already mated is that when I've got two parts like this, and I just go to mate them together, sometimes I can get results that I don't really want. In this case, that one looks all right. So I'll bring that down, but see, as I like drag, it's kind of moving everything. I don't really want that. In this case, it looks to be okay. So I put those two on. I've got another one here. Now, this is an example where I'm doing multiple mates in a row, multiple mates. So I leave the mate tool open, which means I just need to make my selections and it will add the mate. And I can press the tick and it'll add that, and then I can add another one. In this case, I'm going to add one here. So this is an example, like it's kind of rotating around where I don't really want it to. But we'll just go with it. I think it'll be okay. That to that. And then just want to line up. So I can't do the final. I can if I do those selections. Okay. That's all right. That looks okay. Now I'm going to grab that little group. All right, maybe this will work out okay. Let's go to the next step. And we can see I need to put it in this position over here. So I'm going to grab that face and that face, go concentric, and what's it doing? Is it upside down? It's obviously upside down. So I need to go here. Now here's another way you can flip the orientation of a mate. Sometimes it's flip distance or dimension, other times it's flip orientation. This one, I've got the circular mate here and here. I'm going to right click and go flip mate alignment. And that flips the whole thing around for me. And then I can add my parallel and go here and add a coincident. Nice. All right, that looks pretty good. And then we have another one of these. So this part here, I want to put one on this side. I'm not going to use a mirror component, even though I could if I really wanted to, because I have a plane going through the middle of this part. That plane there. I can use planes in parts as reference for other components or features, like a mirror feature. But I don't want to do that. Instead, I'm going to hold Control on my keyboard, click on this red one, drag it across here, and then add some new mates. We'll do the same as we've done earlier to get it lined up. Nice and quick. So you can see once you've already got parts out there, very quick to just click and drag, save, use shortcuts to keep moving with the assembly. All right, and so we've got left and right versions of this part. So I'll bring them both down. This is the one to go on this side, and it looks like these two concentric. And then let me just bring it back up. There we go. Looks like these two faces should be coincident. And this one and this one, parallel. Now, how does our angle look? Is it supposed to sit off like that? Yes. Cool. So that looks good. We'll put this one on the other side, and then we'll update the mirror feature. Right, so now here's another little tip. I've got the mate tool open. So if I click something, it's going to make it as a selection, like, okay, you want to make a mate from that to something else. But if I want to move the part before clicking, then don't click and let go. You can click, hold the mouse, and then you can drag to reposition, then zoom in, then click, and it's much easier to make your selections. So click and drag. Click and let go if you're trying to make a selection. Nice. Okay, good number of steps. We'll get this last one in and then do our mirror feature. So another concentric mate there. Coincident mate here. And rotate that around. These two coincident. Cool. All right. Going to save. I'm going to drag all the mated parts that I can see down into my assembly folder. All right, we're about nearly halfway through using those parts. Now I'm going to update my mirror component. So I'm going to edit that feature. And it's a feature just like anything else in SolidWorks. Any other, like a part feature, you can edit it and change it, delete it. And so now I just want to add in more parts to the mirror. I'm just going to select those parts. Very simple. And then I'm going to press OK. And if they look good, I'm going to keep them. But you can see these triangular ones, I'm getting some issues. So I'm going to edit the mirror components feature, click the arrows, find the ones that are being funny. It's these wedge corner ones. And just see if I can change the setting. If I can't, which unfortunately looks like I'm not going to be able to get the right setting, I'm not going to go through this component orientation axis. Should I try it? Align to this. Align to this. Flip, 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 flip. No. How about if we align it to this? I've got to make a selection. Plane or planar face must be perpendicular to the mirror plane. That one. No, no, no. How about this selection here? No, no, no. Okay, so I'm going to remove those parts. Press OK. And I'm just going to make them manually, which means adding in more parts. We showed it earlier, so I'm just going to duplicate that by holding Control and do another one over here. So instead of trying to fluff around and getting all the mates or getting the mirror feature perfect, sometimes it's easier just to create more of the same part and add in the other mates that we need. It's only going to take me a few seconds. Couple of selections. Right, those ones are added. And then do this set over here. Oh, can't see it. eccentric. Coincident. And one more. Coincident. Cool. How's everybody going? Anyone that is following along? Excuse the coughing. I'm nearly all better. Nearly all better. I'm going to save that. And keep moving. But now I've got, and he's here. It's a great time to answer Edward's question. So Edward, who's in the stream, is in the Skool community. And he posted a question for me earlier, which was, love it if you could touch on large assembly management, since that's something I really struggle with, specifically when I have a big assembly with nested sub-assemblies. Mates often go inactive or start behaving weird, and I run into a bunch of errors trying to fix them. Tips or best practices for keeping large assemblies stable. All right, so this is partly to do with sub-assemblies, which we don't have any yet in this file. I'm wondering if I should open one of my Lego parts, which could be a good little side experiment. So let me just open another SolidWorks. Now the reason I'm opening another SolidWorks is because I might have parts that conflict or cause errors between the two files I'm about to show you. So a few things about dealing with assemblies or large assemblies. First, if it's really like super large and you're getting really lots of lag, there isn't a large assembly tool in SolidWorks that you can use. I'll show you where to find it. Just need to get this opened. And I'm going to open one of my other Lego files, which we find here, which is available through the Skool community as well. That's the motorcycle. And the motorcycle that I've got does have a sub-assembly in there. So I might use that as a bit of reference, and that's why I'm opening it here to explain some tips for managing the larger files. So with managing sub-assemblies, one thing Edward's talking about is how the mates are managed. So your mates in a sub-assembly are contained to that sub-assembly, but when you've got the sub-assembly up a level in your larger assembly, the general assembly, you can still suppress mates and turn them on and off and edit the sub-assembly like you would a part. So you can do editing in context. And if you start to create references or mates that go between the sub-assembly and your general assembly, and then things change, it can get messy. I think that's part of what he's explaining. I think his question also touched on, if I just have a look here, the nested sub-assemblies. And what that can be to do with is, if you're in an assembly and you create a sub-assembly from the parts in there, what will happen is the mates that are just between the parts of the sub-assembly will get nested into that new sub-assembly. All the mates that are not internal to that new sub-assembly will stay in the larger assembly. There's a lot of assembly words going on here. It can be a bit tricky to explain. If we look at the mates folder in this file, I have a couple of mates here up the top, an angle mate, and then I have a folder for all the standard mates. And I think as I was going through this project, I had a lot of things there, and so I created a folder just to hide them so that I had some more visibility of these mates. And this assembly has a sub-assembly in it, which you can see here, the front wheel sub-assembly. And if I press the drop-down arrow on this one, you can see it has a folder for mates as well. And as I was mentioning earlier, I can edit these, like I can edit the feature. If I click edit feature for any of these mates, it's going to take me into edit component mode. Right, so you can see edit component is now on. All those mates are blue, showing that they're active, like I'm actively editing this subassembly. This subassembly is blue, showing I'm actively editing this. If you're trying to get your handle on dealing with mates in a larger assembly context, try not to add mates when you're in the next level assembly up. You know, don't do this edit component thing. Turn that off. Open up the subassembly. Do any mates you need to in this file. That will save you a lot of trouble. I mean that anything you're working on, it's contained in here. If you start to find, as you go through the project, and as you clean up and organize your files, Edward, and for anyone else, you may have a lot of inactive mates that are now redundant or obsolete. And you can see in this file here, I've actually got some. I've got, well, these mates here actually link to this multi-board snap. The multi-board snap is the part that I've designed up there on the wall to hold that motorcycle. You can just see it over there. I won't get it. Leave that for another time. Okay. But there's a lot of other, like all my mates here, I've really deleted everything else. There's not much that is suppressed or not needed, just those couple at the bottom. What can happen is as you're developing, as you nest sub-assemblies into another one, mates become redundant. Just go through your mates folder and clear them out. Another thing you can do to organize your mates and organize your assemblies, like I've done here, you can create folders and you can also rename them. So in this assembly, there's a couple of really key mates, like here. Just for display, I put this on an angle, and I've just named that mate front wheel angle. And that helps me know what that one's for. I've got one here for the seat bounce. So this seat can move, or the sub-assembly. Hold on, is it about to do it? That's fully defined at the moment. Oh, it's fully defined because of this mate, but if I suppress this mate, then this seat can move up and down. Right. So sometimes adding descriptions for those mates will help you understand what they're for, help you know if they're one that you need to keep or not. Often you might find a lot of coincident or concentric or parallel mates that are suppressed because they're no longer active. If everything you've got is fully defined, you don't need those mates. You can just go through and delete them to clear things out. And if you're running into a lot of errors when you're trying to fix mates and your assembly, just clear out the mates. Clear out the ones that are causing errors. I usually start, if I had an error, I'd start with whatever mates at the bottom because they're the ones that are added later. So you just grab those mates, delete them, and try and work out a different way to correctly fully define your assembly. Edward, I hope that helps. If you have follow-up questions, let me know. And for anyone else, if you want to ask questions, feel free in the chat or jump in the community. Send a member request, get in there, and you can post and ask questions anytime. Okay, we are halfway through the stream, and the little man here on the assembly is not halfway through yet. So this next hour, we're going to really power through to get this done, because I do want to wrap all of this assembly up in one stream today. Edward, you're welcome. All right, so let's go with our next steps, and we're going to move a little bit quicker. We've given lots of tips so far, which I'm sure will be very useful. But now there's going to be a little bit of repetitive stuff, I think. So let me just try and move as fast as I can through this. So I'm going to probably start using my space mouse. I always need a bit of practice working with this too. So that's what I use on my left hand. Ooh, don't want to do that, mate. Parallel. And using the space mouse, what it can do is let me flip to more quickly get to the different views that I need for mating. So remember, only doing one side at a time, because I'm going to mirror everything else. I'm going to mirror everything that I can to save time. Now, I think I just put that mate in the wrong spot. This one. So I'm going to edit that, change the selection. Good. Next one. Good. So 2 clicks and then right click for OK is another little quick, easy step. Just going to see if I can mirror that curved part. If I can't, I'm just going to put another one in very quickly. No, can't do it. So let's take that out and just put another part in. Hold Control, drag, move across. Okay, step 16. Another 2 of those parts. So, Control. Pardon me. Concentric. I wonder if those parts, the alignment of those parts needs work, probably. As far as dimensions go, I might have to tweak those. We have this one over here. It goes on this side, I think. Now, so yeah, everything keeps like jumping off camera. It's a little bit annoying, but it's not going to slow me down too much. I'm moving up and down pretty quickly with the scroll wheel and the space mouse. All right, now we need the long grey one. I think it's this one. That's going to sit inside. Does this part have any circles? It's got this, so I can use that to mate. That's going to mate with this concentric. And I'm going to bring that up, flip it around, make these parallel, and get this on. Whoa, don't want those selections. Want those two. Coincident. Good. Next step. A red one at the front. Okay, so I think I put these 2 parts 8mm apart. Yep. So that little round cut, that is going to match with this one. So I'm always just looking for, the shortest, the quickest way to mate and orient these parts. If I've done a feature, if I've done some geometry in the part when I've created it, I may as well use it when it's coming to mate time. All right, the next step, it's a bit of a bigger sub-assembly. So we will create a sub-assembly from that. Just before we do, I'm going to update the mirror components. So I also want to mirror this one. And missed one more part. Want to mirror this one. And missed one more. This one. Okay, that's looking pretty good. So sub-assembly. we're going to leave all these parts here to move into the assembled folder, and a few more. That one. We can see everything that's fully defined, that moves into the assembled folder. And mirror components folder stays down there. So we've still got quite a few parts to go. Let's grab all the parts we need for this sub-assembly. So I've got this one, and I've got another one of those round ones, which we put on the back of the device, back of the model. So I'm going to control, drag that, bring it over. Green square, bring that over. So here's an example where I'm just going to bring all the parts kind of close together so that hopefully I can do the mating as quickly as possible. Duplicate that one. And I've got this black one over here. I've got this small step. I've got this green 4. I think it's this one, yep. And I've got this part, and this little green one, and this grey one. And then it's gonna mirror them along the green one. Yeah, so this little sub-assembly is really starting to capture a lot of the parts, a lot of the remaining parts. So when we get through this one, I think we'll be a long way close to finishing this model. It's going to have those two as well. It's almost everything. And another one of those. We've already got those. Okay. So I've got all the parts to do this little sub-assembly. And it's going to start from this one. Now, just to get the alignment right, I'm going to flip that one around like this. And, ooh, do we want to put this in a little sub-assembly just as practice? I think, why not? Because what that means is so what we can do, I can select all those parts, I can right click, I can go form new sub-assembly. Now there's no mates for all those parts, so it hasn't created a mates folder, but it has created a sub-assembly which I can then open, which means now I only have to deal with these files. All right, so that becomes a little bit easier to manage. And then I can grab this file. This is going to be my first file, and get this one to match up and be fully defined in this sub-assembly, which is, I think, going to then save me some time or make it easier to put everything together in this. So we're going to try and kind of speed assemble this little sub-assembly. So let's see how quickly we can do it. We start the timer. Timer. There's no built-in timer. Oh my God. Clock. Stopwatch. Give me a stopwatch. So annoying. Never mind. It's 10:18. Let's go. Let's see how quickly we can do this. This could be a challenge for Too Tall Toby's community. If you don't know who Too Tall Toby is, he leads website Too Tall Toby and speed modeling, which I've learnt a lot of efficiency tricks from. Highly recommend. That's a good idea, Kev. Too Tall Timer, practice model and use the timer. Yeah. I might actually submit. I wonder if he would let me submit it as a part. He needs some assemblies, I think. Could be something a bit different. Okay, there's that first step done. Next, larger one. Right now, I'm slowed down by my computer, I reckon. My mind can move a lot faster than what this can. Or what my hands can. I think my hands are the slow culprit in this one. All right, another one of those. We're going all right. I wonder how you'd make the challenge. You have to get everything fully defined, or maybe it's just in the right location. But I guess for Toby's models, you're never downloading files, you're just screenshotting a drawing. So that's probably the tricky thing. People might not want to download files to do a challenge. That's right, we might do our own speed assembly challenge. Sometimes Toby jumps in the stream. Seen him once or twice. Might be a bit early for him today, but that's cool. Now, this part here, we've lost it, this one. See, everything's kind of in the wrong position. Just makes it harder to move around the view. Like even here, I'm just trying to get this close so I can get on the underside in both views. It's not working for me. So just get as close as we can. Go coincident. And I might, on this one, if I've got a plane through the middle, right plane, I'm going to use that. Right plane. Yeah. Probably around 6 a.m. Yep, that's right, I think. Now, where should this be mated? I'm going to guess it's going to be perfectly on this face. Yeah, that looks all right. We've done that step. Next, we've got a green. The green one. And that's, so those two concentric. Bring this up. Means these two concentric. Coincident. Yeah, one on the end. Come on, move. There we go. See that interference there? We've got an issue. There we go. The first part we've seen that's got something wrong with it. Interference detection, we might look at a little bit. We're going to see how we go for time a bit later. But I reckon right now, this part, we might just fix it right on the spot. I wonder if it's this one, undersized. 3.2, 3.2. So what should it normally be? 3.2 times 5. 3.2 times 7, 22.4. I reckon the black part is oversized. So this one. So if we edit this component, it actually won't let me edit it until I've saved the assembly. So I'm going to save the subassembly, save as, and I'm going to say subassembly. Once I've saved the subassembly, then I can edit the component. Now I'm editing the component. I can see the height 15.9. That might be the right measurement, but I think it's what's putting the whole thing off. Might be 15.8. No. No, that's interesting. 16 is the right number. All right, no problem. I've got the part here, I might remeasure it later. Next steps, but we want to finish this as soon as we can. Well, as quickly as we can. We want to make sure we get it all done in the stream. Now, this one had a round point that we can make it concentric with. Where is it gone? It's over here. Parallel. Coincident. Hello, anyone that's joined the stream. You can download all the files available in the description. SolidWorks 2023 or newer required. Once you have the files, you can follow along with the assembly. Right now, we're working on a sub-assembly, which is going to take us to pretty close to completed once it's done. And then I'm keen to maybe play with a little bit of rendering if we get done. Now the green one we're going to mirror, but this one here we're also going to mirror and change the color. So we'll leave that for now. Bring this one over. So the way the parts are made, all the different colors, the colors are in configurations. That way I don't have to have multiple parts, multiple files for the same part. There's just one file per part, and then configurations control the color. And so if I come across a part that I've already made before, I can reuse the model and just add a new configuration with a different color. This also means that I can change color on the spot by editing the configuration, the current configuration that's used. All right. Let's move these a bit closer. Oh, they're a long way away. Move them over here. Move them over here. It's better. All right, they're a bit in my view, but I don't mind now. I want everything a little bit closer. And where's the flat one? There. This one have any round bits under it? No, it doesn't. So this one we want to look for right plane. And then I can see it inside here. It's a bit annoying. What I have to do is grab that and drag it up so I've got access to it. And then I can get it in the right position. And then the next one, we have to get this position right. I'm pretty sure it's going to be, what size is that? 7.9, yeah. So we can do the width mate like we did before, or we can do a symmetric mate, which means 3 selections instead of 4. So it's going to put the plane in the middle of those other 2 selections. That's good. All right, these parts here, this one goes here first. We won't be able to mirror those. So before I get to that step where I need the next one, I'll probably mate it in place. Wrong selection there. Concentric and coincident. Very good. And then this green one over the top. that have any round parts on it, round features? Yes, it does. I wonder if it's going to be in the correct position. Now we're going to flip that. Good. Make that and that parallel. Yep. And that coincident. Now that might have some interference underneath it, but again, we'll leave that. Okay, it says flip around the other side. I'm going to put one of these on. So I'm just going to put the one on that is already matching the right orientation, because it makes it easier. In saying that, I don't have an easy mate for this position, so I'm going to say these two coincident. And then how big is this section? 8.3. I'm going to grab this one and the right plane and use a distance mate. So it's going to offset it a gap. Now I want to make sure it's the right gap. So I just put a big dimension in, flip it, and then I put the actual dimension in, and so then I know it's on the right side. And this has another one of these parts, but a grey one. So here's the example, the configuration. I select this, change the configuration. No, it's the wrong part, sorry. It's one of this one here. So let's rotate that around like that. Is there one of those? Yep, just one. So these two holes are going to line up. And this should line up. This, and then we can select these two, make them parallel. That fit looks pretty good. Kev, next two parts I need to make a minifig skeleton arm and a Technic axle bush thing. Technic axle bush thing I think I have. You could probably download one from my library if you wanted to. But they're pretty easy and fun to make. The minifigs though, I haven't done any minifigs yet. I'm looking into it, whether I should do one, whether I do Boba Fett or someone else. We'll work that out soon. All right, so we're at the end of this part now. I think the next couple of steps are all the mirror and then putting these two last parts on. So I'm going to do the mirror, a right plane, first let's save, right plane, mirror component. I'm going to select all the components we're going to mirror. So it's quite a few. 1, 2, 3, 4. Is that it? Maybe this one will mirror. Okay. Yep. Looks good. This one we don't need because in our assembly, we'll get the orientation right in a second. One of these is going to change color. If we're looking at it this way, this one. So I'm just going to select this one and change it to green. And it just changes that version there. The others stay the same, keep their same color. And then I need to put this plate down on the other side. The color's wrong. I'm just going to grab this color and paste it. And, oh, I missed a part. This black part, that one needs to get done as well. So put that in. So now I can mate these two. Looking good. These two and this. All right, and now the sub-assembly I think is done. Quick spin around. Quick spin, looking pretty good. Everything's fully defined. If you look at all our mates, all our parts, part down here says fully defined. It's good. I'm going to save that. And I'm going to save it. I'm going to close this file. It should already be open in the assembly as the sub-assembly, which is here. Okay, and now we just need to put it in the right location. So we just orient our part the right way. It says to rotate it around. Now if we just match the picture, and then we're going to grab this one, I'm going to rotate this one around. That looks pretty good. And so then we can, I think it's going to drop down onto those. So does this have any holes? Yes, it does. It's going to make it easy to line things up. And I can then use some other faces just to be parallel. And then one for coincident. There we go. Sub-assembly dropped in and looking really good. Fantastic. I'll drop that into the assembled folder. And so now there's only a couple of parts to go. How are you going? Everyone following along? I think we're going to hit our timing target and get this done and experiment a little bit with some other tools. A little bit of interference detection just to see what interference exists, and then some quick rendering, but probably not in SolidWorks. We'll see. All right, step 36. So I'm going to match the orientation on the screen. I've got one of these. It's going to kind of rotate the part. Now I don't think there's any circular details on this that I can use to align it. So I have to do it by other means. And I think what those other means are is maybe this face and this face, making them coincident. And then this and this being coincident. And let's see if that works. All right, and then I have to, what do I have to do here to line them up? I can select that part. I can select the plane going through the middle of that one. I can select this face and do a distance mate. And it's going to be 0.1 of a millimeter. There we go. Let's flip that across the other side. Do the same thing. I want to grab this face and this face. Coincident. Flip. Yep. And these two I can make 0.2 millimeters apart. And if all our dimensions are correct, then we'll have no interference there, and that'll be great. Let's check if the mirror component will work for that. I think it should. Nope. Oh, man, that would have been nice. Curved. Why won't you make, flip the right way? Or is that right? No, it's upside down still. So annoying. But yeah, there's probably quicker ways to do it. Those kind of parts. If I had just, if I was kind of lazier, we could probably used the mirror components and made the duplicates of the parts, but then I'd have other parts in all my folders, which I don't want. Trying to keep those folders clean. So I've already got some of these in the right position. So adding a couple of mates to get these in the right position doesn't take too long. Concentric is a good mate for this that I actually didn't think of until just now. As well as like, you know, parallel, coincident. Yep. All right, got those done. Now there's a couple of bits that go onto those outside ones. So that's one of these and one of these parts. Right, so we're going to go this and this, concentric, and I want to flip the orientation. Yep. And then I'm going to put this face onto this inner face here. And then that part can rotate, that's okay. This one I'm just going to rotate. It sits underneath it actually, so it's going to be these two concentric. And this under this one. Yeah. Let's bring it around. And does it have a hole underneath? No. But I can just make these two parallel. Get that fully defined. I have a feeling that that doesn't want to, it's not going to want to mirror that triangle part either. Bit annoying. Should mirror this one okay, but this one maybe not. Yeah, that's right. So again, we edit that mirror component. Take that one out. I'm just going to have to add another one across there. Right. Grab that and quickly mate that one, that one. So anyone else watching have any questions about assemblies? Any little tips or tricks you're after? How to speed things up? Or anything you've seen me do you want to ask about? Now is the time. We've done those green ones. Yep. We've done this one. Yep. All right. Up to the housing lid. So these two concentric, but we're going to flip the orientation. And then this so the windscreen here, going to right plane and right plane it. Get it nice and centered. All right, we'll leave that one open for now. Then we're right at the last steps here. So this has one of this on this, flip, and then I think that face goes up to that one. And then this one here, these two, we're going to flip those. And then I think that face is going to hit the end of this. And then these little shooters, they go into these concentric. And if I'm right, I think it's going to back all the way up to that edge right there. Nice. Edward, can you make motion study according to the mates you have applied? Yes, you can. I will show that because that's a pretty quick and a pretty cool trick that we can do. So I will show that before we finish. So we've done 2 of those, and would you believe it? That is the last step. So we're going to mirror those. And let's just then look at all our parts. Assembly ready. Those were our last parts. I'm going to drop those into the assembled folder. I'm going to delete the assembly ready folder. And now we're going to fully define it. So everything that is underdefined, we're going to fix that up. So everything is fully defined in the assembly. And I'm going to close the instructions because we are done with those. So save, and then let's work out what we need to fully define. So this tile here, it's just a round part that can rotate. So I'm just going to grab a plane, let's say the front plane, and make them parallel. And that stops that one from rotating. Now that could cause me an error if I wanted to flip the rotation of the whole assembly, but I'm not going to do that, so it's not going to be a problem. Similar thing with the lightsaber here. Front. Let's just make those parallel. And we've got a Technic pin. Same thing here. Front. So it's just going to straighten it up. Yeah. Stop that from rotating. Wedge plate. All right, so these ones can currently rotate. So we could set them to be parallel, or we'll set them at an angle. Let's just make them parallel. Good. Windscreen, and then this one. If we've designed it right, we should be able to get it to sit flush here, but let's just try parallel in case there's an issue. It's okay, there's a little gap. I'm happy with that. And then this dish on the rear, very last one, I think. Front plane, mate, get them parallel. And now our assembly is fully defined. See the name down here. That is all done. So what do you think? Not bad. Not bad. Let's change some appearances. Cartoon. No, I don't want that one. Perspective. Shadows are funky because our assembly, we assembled it like this. That's fine. I'm not worried about that. Let's turn shadows off. Looks pretty neat. So, 2 things we'll do. Interference detection and then the motion study according to the mates. Let's turn off all these settings first. All right. So interference detection. We're going to click on evaluate, click on interference detection. We're going to keep everything as is and click calculate and see what comes back. All right, we have 183 interferences, but some of them are really tiny, so not a big deal. Let's just start with the big ones. All right, now what I like is to make the interfering parts transparent so I can see what they are. In this case, it's a part down here, and it's this panel and this bracket. So those 2. And if I click on this, it's going to show me what they are. And then if I want to do some editing, I'll just press the tick here to get out of the interference detection, and I'm just going to click these 2, and I'm going to isolate them. So I'm going to right click and go isolate. So now I'm just looking at these two parts. And so let's have a quick look at what that interference is. And we can see that this one, I think it should have a hole in the top of it. And I think that's the problem, that I've missed putting that detail in. So that's not great. I've obviously missed a step. Now, if I pull apart my little Lego that has that part on it, I can verify, validate, check, and okay, I've noticed the issue here. All right, this part is correct. There's no hole in top, no problem. But, so close that. This part is wrong. And the reason this is wrong is I made this from another one originally where it was half the size. And so it had one of these in the middle. But the new one, when I go to this size, actually has two that are separated. So I have to update this detail. And it's not going to be in the middle like this. It's going to be to the side. I'm going to use the right plane. I'm going to mirror those. I'm going to dimension them, 8 millimeters. Press OK. Save the file, close the file. And what's happened now, the positioning is off. And I'm looking at the mirrored component here. So I actually want to get out of this and find the original, which is over here. So these two parts, I'm going to then look at these two. And now I'm going to find the mates related to these two. So it's this concentric one. And I'm going to change it. I'm going to remove it from that big stud on the top and put it to this one on the bottom. So now it's centered. Is that right? Oh. No, that's not right either. I might have to go back to the assembly. So it does sit on the side. That's what I've missed here. I'm just going to delete that, mate. Press OK. It sits on one side or the other. I just have to find which side it sits on. And to do that, I'm just going to roll back the mirror component. I can see the original. Okay, it looks like it's supposed to sit here. So what I'm actually going to do is grab these three parts, isolate them, have a look, see what's going on. Okay, so these two are what I should be mating because they're going to be aligned and they're kind of lined up in the gap. We can see that now. So I'm going to try assembly, mate, makes those two concentric. Right, that's now fully defined. And while I've got just those three parts here, I can do the interference detection again. And if I want to, I can go ignore hidden bodies components. So it's just going to check what's visible. And now I've only got this very tiny interference, which this kind of interference could be the intended interference from Lego for how the parts snap together. So I'm not going to change that one. I'm going to press the tick, exit isolate, just do a rebuild, and just show. Looks like I've lost them. I'll roll down on the mirror component. All right, and now everything is fixed up much better. And so if I do now the interference detection again and go calculate, then it'll come up with the next biggest interference. for me to address, which is around this bar, right? And so that's how I could go through the model, tick things off one by one until I get rid of all the unintended interferences. And I'm then more confident with my design, my assembly. This one should be a pretty easy one to check. Once I get the calipers out, I'll be able to measure it and put that back together. So yeah, it's probably like the interferences that I need to fix from this model are going to be those big ones. Looks like there's one here. Looks like the position that I've used or the detail that I've done on the interior of this part needs some adjusting. Okay, or the position of those needs to move out slightly. So those parts are going to need some work. That's all that series of interference. And so that's common. Like often I'll find, you know, all those big ones there, they're just related to two parts. The next one down, another sort of curved part, there's an interference there. So again, that might be to do with the position or detail I've done. All right, what else? We get one on the inside here. All right, so I might go through and clear out like the first 20 interferences, but then when we get to these kind of smaller ones, well, that one's probably still a bit big. Let's get down to this sort of size here. These are the ones I'm probably not going to worry about because I think they're part of the clipping features that Lego have. Okay. All right, and then motion study. Okay, so don't use motion study a whole lot, but it can be really handy for like doing simple animations. What I was thinking, Edward, was you've asked it according to the mates. I was actually confusing your question, the mates, with an exploded view. I haven't done an exploded view yet. If you've done an exploded view, then you can do a motion study that's linked to the exploded view. For that, let me open up another file where I've done one before. To do the exploded view, it's going to take step by step. You've got to add all the parts together. What I would do is I'd go through the instructions, and for each step, I'd just slowly bring the parts out. But that can take a little while. I've done it before for the off-road buggy, so I just wanted to show you that because that is pretty quick. Well, to explain, show once you've got all the exploded steps done, becomes pretty quick. I expect opening this file that I'll now get some errors because I've been changing some of the parts around and I haven't gone through and fixed them up yet. So let's see what happens. It shouldn't take too long. And I know that I've already done an exploded view in this file. That's why I'm opening this one. Because I've done a motion study of this to create an animation. I haven't really posted that animation anywhere too interesting or important. Got it saved. Maybe I'll do a key shot animation one day. Just depends. Let's see if we get any errors first. A couple of errors in the mates, not too many. That's all right. Okay, so if we look at this one, this has a couple of exploded views. So I've got one here and then one here. Don't have the big exploded view I was expecting. If we look at the motion study, yeah, okay. Due to model changes, following components or features cannot be set to their locations. That's a little bit frustrating. Let's see what happens if I press play. It's just going to rotate. It's not going to show the animating parts. All right. So I might close this, Edward, and to answer your question, I'll show a very quick exploded view, steps with the assembly we've done. So we go here, assembly, exploded view. Let's just do these caps on the ends. So let's say I wanted to explode these. So explode step 1's going to shoot them out. And then let's say we want them to separate, kind of like missiles or whatever. They're going to shoot off. And then the last bits here are going to shoot off. All right, so that's our exploded view. It's got 3 steps. I can right click here and go animate collapse. And it's happening really slowly, but that shows me an animation, very quick and dirty. If I open up motion study, I can go into motion study, I can click on animation wizard, I can click on explode, next, duration, 3 seconds, finish, and it's set 3 seconds because it's using 1 second per step. And if I press play, it's going to do a motion study. And if I change this to loop or reciprocate, it's just going to keep going on and on. And so exploded views are the keys to doing the motion study rather than your mates. Your mates don't matter so much. Hope that answers your question. All right. Well, I think we've done really well in our 2 hours to get this done tonight. Anyone following along, hope you enjoyed it. Hope you got some really good tips and tricks from putting together this assembly. It was a nice, easy one that we could do in a relatively short period of time. I will be cleaning up the file, and once I've cleaned up the parts, I'll put the lessons into the Skool community. So if this was something that you've caught the end of the stream and you want to go through the whole process of building the parts or putting together the assembly, that's where I'll be posting the lessons. I'll probably post the video on YouTube as well. But yeah, this was a good little fun one. I have some new larger projects coming soon. I'm working on a couple of, let's say there's a SolidWorks fundamentals book in the works, which might be published soon. I'll have some more all the Lego stuff into something a bit bigger that people might be interested in. So thank you very much for everyone that jumped on and was part of the stream today. Het Patel, FPV Kev, and Edward, Christopher Candiotes as well. Thank you guys. Appreciate you being part of it. And yeah, look forward to seeing you in the next one. We'll have another stream in 2 weeks where we'll do something a bit different again. All right, have a good night or day, everyone, and I'll catch you soon. All right, bye.